So the first question asks, how long is the Balrog's whip? Because it must be long enough to reach Gandalf after it has been falling for 14 seconds. This basically translates to, how far do you fall if you fall for 14 seconds? That very simply is going to be worked out by x equals half of a t squared. And since there is no initial velocity, because it just was falling from rest, and also because we're considering the beginning of the fall to be 0, that's all the equation that we're going to need. So a over 2 is going to be 4.9, because that's 9.8 over 2. And the time is 14. So if I do 4.9 times 14 twice, I'm going to get 960.4. So how far do you fall if you fall for 14 seconds? Without air resistance, 960.4 meters. And if you can reach up to your starting position from there with your whip, then your whip must be that long as well. The second question, assuming no air resistance, how far had the Balrog fallen when Gandalf had caught up to it? So that is going to be 14 seconds plus 21 seconds. Hold on, I've got to check that time. It was, let's see, 3:42. Gandalf, let's go for 3. Here we go. Gandalf catches up at 4:21. So that would have been almost a full minute. It was 7 seconds short of a minute. So that was 53 seconds. 53 seconds. So how far had how far had the Balrog fallen when Gandalf caught up to it? That would be falling for 53 seconds. So we just have to do the same thing except for 53 seconds. Okay, so that's going to be same equation, 9.8 over 2 times 53 squared. That's going to be a really big number. 53 times 53, oh my, times 4.9, 13,764.1. Man, more than 13.5 kilometers. So just so we are clear, that 53 seconds represents the, what is that, the 14 seconds that the Balrog had fallen before catching Gandalf, the 21 seconds that Gandalf was holding on while the Balrog was still falling, and then, oh goodness, how long was that? I'm not looking at the timestamps right now. Okay, and then the remaining 18 seconds that they were both falling together. Okay. Next question. What is the total distance that Gandalf and the Balrog had fallen, assuming they fell 1 minute 46 seconds without any air resistance? 1 minute and 46 seconds is 106 seconds, so we're just doing this same thing again. X equals a over 2 t squared. It's 9.8 over 2. This time it's 106 squared. That number is going to be ridiculous. 106 times 106 times 4.9. 55,000. 56. 55,000. 56.4 meters. Now, just noting all these digits. Boy, this is really getting away from us here. So in terms of significant digits, we've really only got two from 9.8. So if we're going to be proper about this, the real answer to this one should just have these 2 digits and be 960. This should just have these 2 digits, and it should be 14,000. And this should have just those 2 digits, and it should be 55,000. Just making sure I'm following the rules. At what speed would they have hit the water at the bottom if there was no air resistance? For this one, I'm going to bring in that new equation because it's going to save me some steps. Actually, it's not going to save me some steps. I just want to show off the equation. So it was 2a delta x equals v squared minus v0 squared. So let's fill in what we know. A is 9.8. So I've got my 2 times 9.8. Delta x is 55,000. And this is equal to v squared minus v0. This is what we're looking for. And this is really very fortunate for us because minus v sub 0, well, that's 0 right there, so I can just leave that alone. So I just need to multiply all that together and take the square root. V will equal the square root of 2 times 9.8 times 55,000. 2 times 9.8 times 55,000. Wow. Okay, well, I think I'm going to need the scientific part of this now. So the square root of 1,078,000 is 1,038. With 2 significant digits, that's only 1,000, but let me go ahead and write that in. The square root of 1,078,000, it's equal to, with 2 significant digits, 1,000 meters per second. That is almost Mach 3. That is not what it looked like in the movie, because it is very unrealistic to remove air resistance. So just looking up the terminal velocity of a skydiver who's in a diving position, as Gandalf was for some of it, that maximum velocity should have been around 75 meters per second. How long do you have to fall to accelerate to that speed? So we're looking for the question here, how long does it take if you're falling at free fall to accelerate to 75 meters per second? So we're looking at this equation right here. T is going to be equal to delta V over A. We're asking for a time. The change in speed is going to be 75 meters per second, and we're accelerating at 9.8 meters per second. So this should be 75 divided by 9.8. You should be able to reach that if you fall, again, 2 significant digits, 7.7 seconds. Now, just a quick little word about realism here, if I could move the calculator out of the way. If we're looking at a chart here, velocity and time, let's say this is your terminal velocity. There's the 75 meters per second. This is assuming that you speed up in a straight line, that's your acceleration, and then once you hit terminal velocity, you just kind of flatline and stay there. That's not how it would really go. In reality, the faster you go, the harder you're pushing the air out of the way, and the harder you push the air out of the way, the harder the air pushes back. So you're likely to have a kind of more gradual approach to your terminal velocity. But that is really complicated physics. You'd have to do like calculus and differential equations and stuff, and that's not what we're going to do right now. So 7.7 seconds it is. It's how long it would take you to accelerate to 75 meters per second if you accelerate at 9.8 meters per second squared. The next question, how far do you fall in that acceleration? We're looking for a distance here, so I can go ahead and use this equation again. The 2a delta x equals v squared minus v sub 0 squared. Since we're looking for a delta x, I can just divide both sides by 2a. And so the distance is going to be final speed minus initial speed over 2a. the initial speed is 0. The final speed is 75. So I'm looking at 75 squared over 2a. That would be 2 times 9.8. 75 squared is 5,625, 5625, and 2 times 9.8 is 19.6. So that's going to give us 286.989, blah, blah, blah. Two significant digits gives us 290. Still pretty far. One more time. Work out the total height of their fall, but this time, assume that they fall at an average speed of 75 meters per second the whole time. How far would they have fallen under this assumption? This is going to be a short little problem, so I'm going to do it in this space up here in the corner. That way I don't need to get another sheet of paper. The question is asking, how far did they fall if they fell at an average speed of 75 meters per second the whole time? We're going back to the very basics, the first equation, that your average velocity is equal to your delta x over delta t, but we're looking for how far. So that's going to be x is equal to vt, plus x0. We don't really need that. Okay, so the velocity we're assuming is 75 meters per second, and the entire fall lasted 106 seconds. So if you fall at 75 meters per second for 106 seconds, you still fell 7,950 meters. Two significant digits, that's actually 8,000, 8.0 times 10 to the third power. Just making sure that you know it's two significant digits there, because if I wrote 8,000, 8000, it's difficult to tell which of the zeros are significant. So 8.0 kilometers, or 8 meters. Now, bear in mind, without air resistance, you would have fallen approximately 7 times that distance. With air resistance, it's going to be somewhere more in that neighborhood. Okay, well, I hope that you found this movie clip somewhat entertaining. Hope that you have this, well, I don't necessarily hope that you think about science when you're watching movies. I want you to enjoy the movie, but I hope it somehow enhances your enjoyment of the movie, maybe even changes which movies you can enjoy for the better. Anyway, that is the solutions. Get a good look at them, and I am all out.